Okay guys, today's video is going to be about more TypeScript types, but also more ways of dealing with types, more ways of guarding against unwanted types or attempting to enforce certain types to be either passed in via parameters or passed out. So before I get started with some of the type guard related information, I want to just talk about these guys, null and undefined. So in JavaScript, null is of type object. It is not of type null. But undefined is still of type undefined. However, in TypeScript, null is of type null. So most of the time, this is not going to matter. But if I'm writing code in TypeScript, but I'm thinking of nulls in the way that I think of them in JavaScript, obviously that can be an issue. So won't come up a lot, but certainly something to be wary of in certain edge cases. Okay, so next one. So in TypeScript, and I wouldn't say that this is an error, but in TypeScript, any variable type can be set to undefined or null. So by default. So if I do this, it will compile successfully. There's no issue. Now, I think that if you're really trying to use static typing in the safest way possible, that you want to use something like a union and enforce strict typing. Right? Now, the way that you can do this is sort of two-pronged, not only by having the union there, but by switching from the default, which is strict false, or specific to nulls, strict null checks false, and switching to true. So then if you do that, then either undefined or null is not going to be an acceptable value type for any type in TypeScript. So in this case, if you want to allow for undefined, you're going to have to explicitly put that put that in there as an option. And then once you do that, everything works again. So not an error to have this off, but certainly a best practice to turn that on and be explicit about all your type declarations and definitions. So the next thing is going to be a certain type. And I want to just type this out first. So in this situation, you have a function that, let's say, did some work in here, and it failed. So it threw an exception, right? Now, clearly there's no error, so TypeScript is not complaining. But again, if we want to do best practices, then we prefer to have some sort of explicitness here. So one way to get that is to describe a situation where potentially a function may never return. Obviously, that can happen if it throws an exception, or if a variable is never set because of some condition, then there is actually a type for that in TypeScript, and it's called never. So I'm going to show you one more example before I show you where this is useful. So let's pretend that we have a while loop that, for whatever reason, just goes on forever. I mean, this is an unlikely scenario, but I just wanted to distinguish and show you that it doesn't have to be an exception that prevents the function from returning. It can be just, an infinite loop or whatever. As long as it doesn't finish, then you have a never return type. Now, this may seem like a waste of time. It may seem like, well, isn't this sort of like what, return void is? They're actually very different. Return void does return in the complete sense, but it just doesn't return anything back. But never actually doesn't complete, and that's what this type indicates. Okay, so what is this good for? So if I am having a string processor function, and let's say that I took this string and I processed it and it was successful, and so I returned it. Now, what if this processing bit up here was not successful? Well, for my needs, I want to return an error. Now, if I return an error, as you can see, the TypeScript doesn't complain. Everything is still fine. However, this breaks notions of abstraction, right? Because in order for me to know that an exception is potentially being thrown, I have to go inside of the definition and take a look around, which is not a best practice. It's not ideal. So one way to handle that, and I'll show you a different way later, but for now, one way to handle that is to use a union that can potentially return never. So by doing that, without even looking inside of this function, I immediately know that more than likely it has the potential to throw an exception if something doesn't work, or at least doesn't work to the desires of this function author. So if I run this code, it fails. Now we'll start talking about type guards. Type guards are mechanisms to allow us to test for certain types or to prevent certain types from being used. Let's start with an example of why that is necessary. So we've been using unions throughout these examples, and they're a great way to have flexibility, but still allow type safety. Now, the issue with using unions is that if you have a situation where, let's say you have here a car and a truck, and they have similar but slightly different interfaces, and then you have a function that is potentially returning either or, and let's say there's some logic in here to decide at runtime, But for now, we'll just explicitly put in a truck. So if this occurs, TypeScript, the compiler, is not going to let you compile. It's going to complain. And I'll show you that right now. As you can see, there's no payload. And if I try to call it, I get this error talking about the union of car and truck not existing. So, I mean, here it's very clear what's about to be returned. So you could make the argument, well, TypeScript, the compiler, should realize that and take care of it. But the issue is that if you have runtime logic, it won't know. So TypeScript is choosing the most conservative route, and it simply won't allow you to do this without proving first that this is of one type or another, which is, again, somewhat similar to my last video about the unknown type. And I'll provide a link below if you want to take a look at that. But so what is one way of overcoming that or of dealing with that? Well, in TypeScript, you have something called type assertions. And type assertions are a lot like casting in other languages, except the casting is, how should I say? It's almost like virtual casting because it's only pretending to cast and it's never actually casting for real. So let me just finish typing this and I'll show you exactly what I mean. So what I'm saying is, if you take a language like C# and then you have this identical code to cast, if the cast fails, then it will actually return null. If you use as to do the cast and it fails, it will return null. In the case of TypeScript, it's significantly different because this casting actually never happens. This casting is purely a compile time, development time tool to tell the compiler, hey, hold on for a second, just trust me for a moment that this object is of type car, and let me try to do this. So when this code is compiled and you have the resultant transpiled JavaScript, you're never going to see this cast. So what it's trying to do is just let you get far enough so that you can try and call into it. And in this case, we know that a truck is being returned, so this cast will quote unquote fail, and therefore this will return as undefined. And so this portion will be skipped, and then it will go into here. So if I show you the running code, let's just do this. Just to make it easy. Oops. I think I meant to put it here. Okay. So as you can see, we already know this was going to be a truck. So the quote unquote cast or virtual cast that was done here was the one found to be true, because of course if this is a truck, then this has a definition, and then this console statement was run. So this is one way of checking for the type that you are expecting and dealing with it. So let's take a look at another one. This time we're going to take a look at type predicates. Actually, let me bring that back. So we'll keep most of the code, and let's pretend that the previous mechanism was too verbose, and also I wanted to be able to reuse it. So what I'm going to do instead is I create a function, and then I say, does this object contain this function? Now, in this case, you're just going to get back a Boolean, and that should work, but it's not as explicit as possible. So if we do this instead, we're getting a much more explicit signature about what this is intending to check internally, again, without actually having to look inside or know exactly what's going on inside. So this is checking the vehicle parameter and seeing if it is of type truck. So if we run this, this should work. Is truck is true. So this is type predicates. The next one that I want to discuss is actually one that I don't like, and I'll show you why. If we create a new function, it'll have the same parameter. This one checks to see if the field exists inside of the particular object being looked at. So obviously that's vehicle. So if it does, then it's going to run the appropriate code. And if it doesn't, then it's going to run the other one. Now, the thing with this, or the reason why I don't like this, is because, as you can see here, it ran successfully. What was expected or should have happened did occur. But the problem is, this is a string. So if I typo it, or type in something that I thought existed and doesn't exist, then I'm going to get not a compile time error, but I'm actually going to get a runtime error. So that's why I prefer not to use this version, but it is an option. It is available to you. Okay, the last mechanism I want to discuss is actually not a type guard. It's actually an assertion function, which is very similar to testing, but basically you get the same effect in the end. So in the case of this example, I'm gonna switch the interfaces with classes real quick. And then I'm going to, since they're no longer interfaces, I'm going to create an instance of this truck, and you'll see exactly why I'm doing this in just 2 seconds. Okay, so this is what I'm trying to do. I'm trying to assert that this vehicle, again, same signature, that I'm going to pass in is of a certain type, in this case, truck. So the way that I do that is I confirm that the parameter being passed in is of that type. And the way that I do that is I check its instance of, which is why I converted these two to classes from interfaces, to be able to check that, because obviously an interface doesn't have an instance, right? So if that turns out not to be true, then I fail out. But if it is true, then I just return. Now, if I wanted to, I could do that and it'll just return void, but fail out if this turns out not to be the case. But again, it's the same problem that we encountered last time, where if that's occurring, then it makes me want to look inside to see why and take a look at the internals and stuff like that, which is not ideal. So if I run this, it still works because we know that we passed in a truck, so it went here. So this doesn't change anything from working or not working, but it is more explicit. And again, if you're using TypeScript, then obviously you're preferring that, and that is a best practice. So that's why this is a better alternative than not using this to make assertions. And that's it.